All right, now we will take a look at a blended solution where we actually going to use a one-dimensional convolutional network in order to do some pre-processing on a long sequence, and thereafter we're gonna use the GRU as we have been using to process these shorter sequences. And the dataset that we will use will be the GENA dataset, or the weather dataset, where we actually have to predict a temperature 24 hours ahead. So let me use that GRU recurrent dropout and make a copy of that file. Here we go. We open the file as usual. And here we have to mount the drive. So, all right, here we are. So I'm gonna let this run, and this I'm gonna call GRU dash one-dimensional conf net. All right, so I can take this copy of out. I'm gonna get my code as usual. Here we are. So the code, let's copy that code. Paste it here. And run it. All right, so now let's go to the bottom where we actually have our generators and everything to see what we have to change. So the first thing we have to change is that steps is going to be 3, 1 sample per half hour. All right. The rest I'm not going to touch. All right, so let's import the necessary libraries here. These are the traditional ones. All right, so now we're gonna build the model. So let me paste a block of code. So this, no surprise, sequential. And here we're gonna add our first one-dimensional convolutional layer, where here the number of filters that we're gonna use is 32. The size of the filter will be 5. And here, remember, we can take a size that is way longer because we're in one dimension. We're just now racking up the parameters by changing this. So activation is relu, and of course the input shape is are the columns of the data frame. Yeah, these are these columns. All right, so then we have a max pooling layer of size 3. Let me change that to 5. Yeah, and then we have another convolutional layer, one dimension, with exactly the same arguments. And we're gonna add a GRU layer here with 32 units and with some dropout and recurrent dropout. And as usual, we have the dense layer as a final layer. And here nothing has changed, so steps per epoch 500, but we're gonna limit to 20 epochs. So let's run this. Oh, invalid syntax. Model add layers, max pooling 1D. Let's see, maybe here there's a bracket that I should put there. Let's run it again. And now it works. Float data is not defined. Okay, that comes because I didn't run from the start. So let me do a run all, and this should be solved. Here we go, another, dense is not defined. I can do imp from Keras dot layers import dance. All right, so let's see if it works now. Yeah, it works. So it will take a little bit of time. All right, let us now plot the results. Here we go. And the validation loss, it's quite flat on average. Between 7.5 and 20, you could make the case that it starts to overfit. But in general, the results are not bad. And usually it's much faster than using GRU by itself.